Welcome to our deep dive into green AI, one of the most critical challenges facing artificial intelligence today. I'm excited to explore with you how we can build powerful AI systems while protecting our planet. Did you know that training a single large language model can emit as much carbon as 5 cars over their entire lifetimes? The AI revolution has brought incredible breakthroughs, but it comes with a hidden cost: massive energy consumption. Every time we train ChatGPT, DAL-E, or autonomous driving systems, we're using enormous computational resources that translate directly into electricity, often from fossil fuels. The problem is growing exponentially as models get larger and more complex. But here's the exciting part: we're not powerless. Green AI is an emerging field focused on developing environmentally sustainable artificial intelligence. It's about achieving the same or better AI performance while dramatically reducing energy consumption, carbon emissions, and computational waste. Think of it as the sustainability movement for the digital age. Let's put this in perspective. Training GPT-3 consumed about 1,287 MWh of electricity, enough to power 120 homes for an entire year. And that's just for one model, one time. When we multiply this across thousands of AI companies, training millions of models globally, we're looking at carbon footprint comparable to entire countries. The environmental impact comes from three main sources: training, the initial model development phase that requires massive compute clusters running for weeks or months; inference, serving the model to users, which happens billions of times daily; and data centers, the physical infrastructure housing all these computations, requiring cooling, power distribution, and hardware manufacturing. Now, let's explore the core strategies of green AI. Algorithmic efficiency means developing smarter algorithms that achieve the same results with fewer computations. Hardware optimization involves using specialized chips like TPUs or newer neuromorphic processors that are inherently more energy efficient. Model architecture focuses on designing leaner neural networks through techniques like pruning, quantization, and knowledge distillation. Carbon-aware computing is a game changer. Instead of training models whenever convenient, we schedule computations when the electrical grid has the highest percentage of renewable energy. Some companies are achieving 50 to 80% reductions in carbon emissions just by timing their training runs with solar and wind peak production hours. Let's look at practical techniques you can implement today. Efficient model architectures like mobile nets, efficient nets, and transformer variants, specifically designed for efficiency. Transfer, learning, and fine-tuning. Instead of training from scratch, we start with pre-trained models and adapt them, reducing training time by 90% or more. Federated learning distributes training across many devices, reducing the need for centralized data centers. Model compression techniques are incredibly powerful. Pruning removes unnecessary neural network connections. Often 90% of a model can be removed with minimal accuracy loss. Quantitation reduces the precision of model weights from 32-bit to 8-bit or even 4-bit numbers. Knowledge distillation teaches smaller student models to mimic larger teacher models, achieving similar performance with fraction of the computational cost. The tools for green AI are rapidly evolving. Carbon tracking tools like Code Carbon and MLCO2 Impact help measure your model's environmental footprint. Efficient frameworks like TensorFlow Lite, PyTorch Mobile, and ONX Runtime optimize models for deployment. Green cloud providers like Google Cloud's carbon neutral regions and Microsoft's renewable energy commitments make sustainable computing more accessible. Looking ahead, the future is bright. Neuromorphic computing mimics the brain's efficiency, potentially reducing AI energy consumption by 1,000x. Photonic computing uses light instead of electricity for ultra-low power AI. Edge computing brings AI processing closer to users, reducing data transmission energy. And AI for sustainability, using artificial intelligence to optimize renewable energy grids, reduce waste, and combat climate change. Remember, green AI isn't just about being environmentally responsible. It's about building better, more efficient, and more accessible AI systems. When we reduce computational requirements, we democratize AI for researchers and companies with limited resources. Let's build the future of AI sustainably. In our next session, we'll dive into hands-on implementation of these green AI techniques.